Assalamu alaikum. This is Sir Fawad Akhtar Ansari. Now we continue our chapter data representation and the topic is measuring memory size. We already studied about the unit of measurement which is called byte, and byte is a unit of data that is 8 bits long. It can be used to represent any character. For example, a character can be a letter. It can be an alphabet or a special character. It could be a number, or it could be any image. We have also encountered computer storage devices such as USB and micro card and hard disk. So these all storage devices consist of measuring memory size, and the measuring memory size depends upon the bytes. First we have to clear the concept between the byte and the bit. We use to represent byte with the capital letter B, and we used to represent bit with the small letter b. This is very much important because usually people don't understand the bit and byte abbreviation, so we must clear it before going further. So a bit is one of 8 of a byte and is abbreviated with a lowercase of b. And now we can see the table or a chart which we use to show memory size. Now here it is. A bit is a 0 or 1. 8 bits equals to 1 byte. 1024 bytes equals to 1 kilobyte. 1024 kilobytes equals to 1 megabyte. 1024 megabytes equals to 1 gigabyte, and 1024 gigabytes equals to 1 terabyte. There are other measurement units as well, but we are not about to study them because it is not a part of the syllabus. But you can see it just for your knowledge that 1024 terabytes equals to 1 petabyte, then 1024 petabyte equals to 1 exabyte. There's one more thing I would like to share with you, that in computers there is a conflict among the computer scientists. One group of scientists recommends that we have to use the measurement around 1024, but the other group of scientists use to recommend 1000 measurement size. So in Cambridge they have just given us a freehand, and we have to follow 1024 measurement size because it is much more accurate. So 1000 is not allowed in Cambridge computer science. Now we switch to the next topic, and it is about the computer mechanism, that how the computer system works. So the next topic is registers. In computer we have already studied about the CPU, central processing unit, since our childhood, that the central processing unit used to control the flow of work and share the information. So there are different registers, and each register has its own work, own task that it needs to perform. So what is a register basically? Registers are a type of computer memory used to quickly accept, store and transfer data and instructions that are being used immediately by the CPU. It means कि register जो है वो कंप्यूटर में एज अ मेमोरी वर्क करता है और इसका डिफरेंट टास्क होते हैं. ये क्विकली एक्सेप्ट करता है डाटा को, स्टोर करता है, ट्रांसफर करता है और इंस्ट्रक्शंस को भी प्रोसेस करता है with the help of the central processing unit. The registers used by the CPU are often termed as a processor registers. अब यहाँ पे different types की बात हो रही है कि there are multiple registers and each register has its own task, has its own job. Let's suppose processor register की बात करें, to So it holds an instruction, a storage address or any data such as bit, sequence or individual character. ये डाटा को, उसके एड्रेस को जो उसका सीक्वेंस ऑफ वर्किंग है उसको स्टोर करता है, प्रोसेस करता है. The computer needs processor register for manipulating data and a register for holding a memory address. कि कंप्यूटर को एक प्रोसेसर रजिस्टर चाहिए होता है जो कि हर रजिस्टर के डाटा को प्रोसेस करेगा, राइट. और उसके लिए एक अलग अलग रजिस्टर है जिसको वो टास्क इशू करता है. The register holding the memory location used to calculate the address of the next instruction after the execution of the current instruction is completed. It means कि एक हमारे पास ऐसा रजिस्टर होता है जो अपने पास हर डाटा का एड्रेस स्टोर करता है. लेट्स सपोज मेरे पास डी ड्राइव है और डी ड्राइव में मेरे पास, मैं एक फोल्डर बनाता हूँ डी ड्राइव में गेम्स का, जिसमें मैं सारे गेम्स उसमें कॉपी करूंगा. एक बनाता हूँ मैं सॉन्ग्स का, उसमें सारे सॉन्ग्स कॉपी करूंगा. एक बनाता हूँ मैं मूवीज का, उसमें सारे मैं मूवीज कॉपी करूंगा. अब यहाँ पे तो मैंने फोल्डर बना दिया, बट बैक एंड पे कंप्यूटर क्या कर रहा है, उसका जो एड्रेस रजिस्टर है वो हर एक का एड्रेस अपने पास स्टोर कर रहा है, राइट. ताकि नेक्स्ट टाइम जब हम अपने डाटा को रिकॉल करें तो फिर वो उस एड्रेस को लोकेट करके यूजर तक पहुंचाए. सो देयर आर मेनी रजिस्टर्स, डिफरेंट टाइप्स ऑफ रजिस्टर है. प्रोसेसर रजिस्टर हो गया हमारे पास, हार्डवेयर रजिस्टर्स होते हैं. हार्डवेयर रजिस्टर के डिफरेंट वर्क होता है कि जितने भी हार्डवेयर आपके सिस्टम से कनेक्टेड है उनके डाटा को वो प्रोसेस करें. एक होता है हमारे पास प्रोग्राम काउंटर, इसी तरह होता है एक्यूमुलेटर रजिस्टर, memory address register, we also used to call it MAR. We also have the memory data register, MDR. इसको memory buffer register भी कहते हैं. So there are different registers and each register has its own job. और जितने भी registers हैं इनकी जो full detail है we will study it in the other chapter. So hardware registers are specific to different types of hardware and are used to convey a signal. अब इसमें ये बात हो रही है कि जो रजिस्टर, हार्डवेयर रजिस्टर है, उसका काम क्या होता है कि वो सिग्नल को कन्वे करता है और उसको मैनिपुलेट करता है थ्रू आउट द सिस्टम. फॉर एग्जांपल अ रोबोट आर्म दैट हैज अ वेरियस मोटर्स टू परफॉर्म डिफरेंट ऑपरेशंस. एक रोबोट आर्म है जिसमें डिफरेंट मोटर्स लगी हैं और उन सब का डिफरेंट ऑपरेशन है, डिफरेंट वर्क है. फॉर एग्जांपल इट कुड रेज द आर्म, एक ये प्रोसेस हो गया. ओपन द ग्रिप, एक ये प्रोसेस हो गया. क्लोज द ग्रिप, एक प्रोसेस हो गया. So each motor works via a signal 1 or 0. 1 means on, 0 means off. So a register used for each motor to convey the signal. A register might be used to convey whether the device is sending a signal to the computer 1 or 0. So it means कि आपके 1 और 0 की importance यहाँ पे आपको realize हो रही थी कि how much it is important to convey a particular signal or not. Now our next topic is hexadecimal systems. We already studied in the previous lecture that the number conversion hexadecimal is there. So it is a number system that is used, of course, in computers, but computer does not actually process hexadecimal. Computer only convert it into binary form because computer only understand its native language, which is binary language. So that's why hexadecimal cannot be processed. It can be converted into the binary form before processing. So the programmers work with the hexadecimal as it is easier for humans to read than the binary, because binary we already studied in the previous topic that the computer used the combination of bits. So we cannot understand the combination of bits properly. So that's why programmers use hexadecimal. So because it is easy for the humans to understand. It is because that it is a much shorter way of representing a byte of data, as reading and understanding lots of bits. In the same way, programs that are written in the hexadecimals are easier to debug than those written in binary language. Of course, binary language, if you use it, you must understand the concept of the coding among the binary digits, that the combination of bits we use to perform a specific operation. So उसको पूरा स्टडी करना होगा, लर्न करना होगा. So it is much hectic and time taking. So in the same way, programmers used to write in hexadecimals because the codes in the hexadecimals are easy to debug than the binary numbers. Now we study about some of the applications of the hexadecimal number. So we encountered in our routine life that the hexadecimals are almost everywhere. For example, we have seen many websites and each website has its own color scheme. So how the color scheme can be generated? So we use the hexadecimal, or we used to call it in the short form hex. So hex is used as a notation for colors in HTML. HTML is a hypertext markup language which is used to develop websites or web applications. So hexadecimal or hex color notations are normally 6 digits, and each hex notation represents a different color. For example, there is a color maroon. You can see the code in hexadecimals. The red hash FF and 4 zeros. Orange hash FFA 500. Yellow hash 4 times F double zero. So there are multiple codes of different colors we can observe in this chart, and there are many other charts are available on the internet. You can see for the color code. So we must learn or understand the concept of color codes, because we cannot memorize each color code. So you can see that the F represents the white, and 0 represents the black. So with the combination of F's and the zeros, we can make the contrast colors. Alright, now we switch to the next topic, media access control. We also used to represent it by the capital MAC, MAC. You have often heard the term MAC address. So what is a MAC address? Basically, it consists of 12-digit hexadecimal numbers that uniquely identify each different device in a network. कि आपके जो मोबाइल फोन्स हैं, tablets हैं, your computers, your laptops. So each device that you use to communicate has its own each different MAC address. A MAC address, of course, could be in the form of this. This is a MAC address that you can see 0010-5A4412B5. So this is an example of a MAC address. We will study more about it in the next chapter. So the machine code consists of simple instructions that are directly executed by the CPU. राइट ये मशीन कोड जो कंसिस्ट करती है वो डिफरेंट इंस्ट्रक्शंस पे डिपेंड कर रही होती है जो एग्जीक्यूट करता है सीपीयू अपने बिहाफ पे. सो हेक्साडेसिमल इज यूज्ड फॉर मशीन कोड एज ईच बाइट कैन बी कोडेड एज 2 हेक्साडेसिमल सिंबल्स. इसकी भी डिटेल हम अपकमिंग चैप्टर में स्टडी करेंगे, बिकॉज इस चैप्टर डाटा रिप्रेजेंटेशन में वी आर जस्ट स्टडीइंग सम एंड सब्सटेंस ऑफ द टॉपिक, एंड ईच टॉपिक इज covered in detail in different chapters. Alright, now we start next topic, which is data storage. As computers can only process ones and zeros, so we know that it consists of binary numbers. So all the data stored on a computer is in binary form. If we had to carry out our daily task on a computer using only binary, it would be extremely time consuming and challenging. It is like agar you want to open a file, so you just click on the folder or you click on the file. But what if you do not need to click? Instead, you have to type the binary code. So it would be difficult for you to memorize the binary code and then execute it. So typing the ones and zeros that represent each character would take you much longer than typing out the characters the binary numbers represent. If I want to type A, and what if I am not typing A, instead I am typing the binary code of the letter A. So you can imagine that how much difficult it would be. Also imagine having to be typed in each binary digit needed to create your favorite images. It would be extremely difficult. Depending on its resolution, a character might require 100 bits of data. An image might require millions of bits. A number of systems and software that were developed to do this for users, and they help a computer to store different data such as text, images, videos, and audios. Now we must understand the concept of text, numbers and symbols using the binary digits or the bits. So there are two systems commonly used for the characters. Characters include text, numbers and symbols. And we use different character set. One is the ASCII, ASCII, American Standard Code for Information Interchange. American, it is a full form of ASCII code, American Standard Code for Information Interchange. And there is another set known as the Unicode. But first we study about the ASCII, American Standard Code for Information Interchange. So ASCII uses only 8 bits of data, giving a possible of 256 that I told you in the previous lecture. If we about to add the number system 1 2 4 8 16 32 64 1 to 8. So this is the 8 bit 1 2 4 8 16 34 64 1 to 8. तो ये 8 bits हैं, but we can increase it by the 12 bit or the more longer bits. तो यहाँ पे ये जो 8 bits हैं, अगर इन सबको हम add up करेंगे, so it forms a 256 character combination. So it is suitable for standard English but does not contain a large enough character set for some other languages. English के लिए तो सही है कि आप English alphabets में आप cover कर लेंगे, but there are the other languages globally, so we have to also cover these languages. तो उसके लिए हमें भी इसके updated version को use करना पड़ेगा, and its updated version is extended ASCII. Extended means के ASCII में further different languages को add up किया गया है on सबके different codes. There is another code which is known as the Unicode. So it is also used to store many other characters. Extended ASCII के बाद आपके पास आता है Unicode. It also offers multiple huge volume of languages data. So Unicode uses 16 bits. It means it generates 65,536. 65,536 possible combinations of characters. In ASCII and Unicode, each character is represented by the binary number. For example, the letter A. The code of the letter A is 01000001. So this is the code of the letter A. इसी का आपका जो small a है उसका अलग code है. Means capital letters के different code है, small letters के different code है. So I would like to show you a chart which represents codes. Now you can see the short table of the ASCII code, and you can see that the capital J has the ASCII code of 74 and the binary number is 01001010. In the same way, capital 0, capital O, capital U, capital R, each letter has its different code. Now we start our new topic, pictures. Picture, of course, it could be an image of a background scenario, abstract, it could be a wallpaper. So an image as we see it is analog data, but a computer will only understand if the analog data is converted into a digital form. So we need to convert analog data into a digital data for the computer to process it. This can be done using various devices such as a scanner or the digital camera. Images are made up of pixels, and a pixel is a tiny dot on the screen. If an image was simply black and white, each pixel would either be black or a white. One number would represent a black pixel and a 0 number would represent a white pixel. if we are given a series of binary digits that we can use in the grid, we know that the dimensions of the grid to be able to create the image. This data is called the metadata. Metadata is what tells the computer how many pixels wide and how many pixels high an image should be. This is the resolution of an image. You can see the resolution of an image below. Okay, now this is a picture. You can see it shows a smiley face, right? So this is a simple picture, but now I convert it into the binary. So you can see that the 0 number used to represent the white color and the 1 number used to represent the black color. So this is how the pixels can be represented in the binary form. I'll show you more pictures like that. Now you can see the image smiley face and the code is in the binary form. You can see here. In the same way, the next picture represents the letter capital J, and then you can see the binary form of it. So this is how the pixels used to convert it into the binary form. Now what if we need more colors to represent our picture? So the image needs more colors, so a computer needs to convert computer needs more data to convert in the digital form. So more binary data means more digits to represent more colors. So the most colors are made up of red, green and blue, which is also known as RGB, red, green and blue. You have often heard the term RGB, red, green and blue. Another term that we used to represent CMYK means cyan, magenta, yellow, black. So CMYK is another term, but it is not used to display images. So we are just cutting it down. Now we focus on the RGB, red, green and blue. So red, green and blue means red color, green color and blue color. The combination of these three colors used to develop another color. This is why image can become large, especially when the images are high in quality, like it could be in the high definition around 720 pixels or 1080 pixels or above 1440 pixels, or it could be a 4K image, 4000 pixels. So the colors and the resolution would be increases, as well as the storage capacity will also be increased. So to get the correct color depth in each pixel to create a detailed image, the amount of binary data needed is much greater. That you can see that the color schemes even here. So you can see the color schemes. More color means more scheme. You can also use this color. So there are the different colors, red, green and blue. If I increase the intensity of red, it will generate other color. If I increase the intensity of green, it will generate other color. You can see the difference here in this bar. If I increase the intensity of blue, it will just go for the black color. Okay, now next topic is the sound. The sound that we hear is also analog, but as we know that a computer works digitally and can only process binary, so we need to convert the analog sound into a binary form for a computer to be able to process it. Sound is recorded using a mic or microphone and then converted it into a binary form by the help of a software. Sound is recorded at the set timed intervals. This process is known as sampling. The samples are then converted into binary. If the set timed intervals are closer together, the soundtrack will be higher in quality. अब इसमें ये होता है कि साउंड जब हम रिकॉर्ड करते हैं तो उसका एक टाइम इंटरवल होता है, मींस डिफरेंट टाइम्स में डिफरेंट सेकंड्स में आपकी पिच सम टाइम्स हाई होती है या लो होती है, तो उसके अकॉर्डिंग वो उसको एडजस्ट कर रहा होता है सॉफ्टवेयर और हमारा माइक इसमें उसकी हेल्प कर रहा होता है. If the set time interval are closer together, then the soundtrack will be higher in quality. कि अगर आपकी एक ही पेज एक ही लेवल पे आपकी साउंड चलती रहेगी तो एक आपको अच्छा रिजल्ट मिलेगा, हाई क्वालिटी मिलेगी सुनने में. Simply with more sample, the sound can be more accurately captured. जितना जितना strong आपका साउंड सैंपल होगा उतनी ही स्ट्रॉन्ग इसकी क्वालिटी होगी. सैंपल साइजेस आर मेजर्ड इन हर्ट्ज. 1 hertz equals to 1 sample per second. For example, a telephone communication samples a voice at 8000 hertz. कि जब आप टेलीफोन के थ्रू आप कम्युनिकेट करते हैं तो आपका जो वॉइस का लेवल होता है वो ऑलमोस्ट 8000 हर्ट्ज होता है. हर्ट्ज इसका यूनिट है. बट अ हायर क्वालिटी, कि अगर आपको हायर क्वालिटी की वॉइस आउटपुट चाहिए जैसे सीडीज वगैरह में होता है तो आपको अप्रोक्सीमेट 44100 हर्ट्ज चाहिए. 44,100 hertz is considered to be the standard sound sample, but it could be increased for the stereo and the remix sound sample. तो इसके लिए हम यहाँ पे देख लेते हैं. ये आपके सामने चार्ट है. Value, sound sampling and time duration. So the pitch or the amplitude of the sound used to vary at a different time intervals. So this is very important for the computer that we need to record our voice at the highest quality so it could give us a good output result. Now we just wind up today's topic, and then our chapter is continued at our presentation, and we will start a new topic in the next class. Thank you very much. Allah Hafiz.